This is Tech Math 2, and we're doing sections 11.5 and 11.6 today. 11.5 is going to seem to be pretty simple. 11.6 is going to seem to be a little more difficult, and luckily we have better ways to do it when we get to 11.7, so that's the way that is. So in section 11.6, what we're going to do, 11.5, what we're going to do is have vectors. So we have some vector A, and we have some vector B, and we're going to find A plus B by a graphical method. So we're going to take A and put him down, and then we're going to put B and put him down, and then we're going to say that that's equal to vector C, and there's vector C. Okay, well that's the plan. So we're going to look at problem number 3. And the first thing we're going to need is a XY coordinate system, so we'll go get one of them. Alright, so now we got an XY coordinate system, so that's pretty cool. And then the next thing we're going to need is a protractor. So we'll go looking for a protractor. Shape, spaces, and measures. And where is our protractor? Oh, getting close. Maybe. Maybe not. All right, let's see if we can do better than that. Interactive notebook pages, backgrounds and themes. Oh, there we go. One each protractor. All right. Now we're all set. And so problem number 3, we have 2 vectors. Vector V is 75 miles per hour at an angle of 345 degrees, and vector W is at 25 miles per hour at an angle of 270. All right, now we'll have to decide how we're going to do the scale. All right, well, we'll call that, we'll call that 25. Then we couldn't get to 75, could we? All right, so we'll call that 25, and that 50, 75, and 100. So that's the scale we're going to use. All right, well, if I look at the second vector, I can see that he's going that way, like that. And then if I look at the second vector, we need to be at an angle. Let's see, how do I make the angle turn? Oh, there we go. So we need to be at some angle. Can I rotate it? Yeah, I can rotate it. All right, there we go. So now I've got some angle, and I want that angle to be 345, which is 15 degrees away from 360. Okay, so I come down this way, and I come down to 15 degrees. So now I'm going to come out that way. So that's the way I'm coming like that. And now the issue is, where is 75 on that? So now I got to figure out how to get out to 75. So it's going to be slightly less than there. So we'll call it, if I had a ruler, that'd be much better. So I'll call that 75. Oh, bummer. Too big. Yeah, so I'll call that 75. That looks about right. And then we'll go in and, well, I know how we can do that. We can go get a circle, put it there, bring it out to 75, and then we can go and bring that circle. No, we can't. All right, so we won't do that. All right, so the answer I'm looking for starts there and goes that way. So now we want to, well, first we're going to find the angle because I got a protractor and that'd be the easiest thing to find first. So that's going to be an angle of 10, 20, 35 less than 360. So 35 less than 360 would be 315. So my final answer, angle 315. And then it's a matter of what is that magnitude. Now, how am I going to figure that out? All right, so I got a mark here that I can't bring with me, and I'm going to bring it up. And bring that mark up, and looks like about 83. What do you think? 83 miles per hour at an angle of 315. And because we're doing graphics to solve the vector, that's as close as we're going to get, and that's then we're going to say, okay, that's fine. All right. So we did this in 6th grade, maybe. Except I think I'm going to need a compass. I wonder if I can come up with a compass. All right, now we're going to do number 7. So I'm going to do the same thing again. I'm going to find myself a protractor. So there's a protractor. And I decided that I need a ruler too. So can I have a ruler? Let's see. Can I have a ruler? Doesn't look like I'm going to have a ruler there. Integers, number bars, currency. No, I don't want currency. Symbols, tools, space and measures. There we go. Space and measures. Areas, angles, maps, shapes, measurements. Measurements. All right. Well, not exactly what I was looking for. There we go. Imperial ruler. Okay, so we'll get one of them. So now I've got a ruler, and I've got a protractor, and now I need to get an XY plane. So I'll go back and get an XY plane, which I know is in that guy, graphing XY plane. Okay. So now I've got everything I want, and I'm doing problem number 7. Okay, so problem number 7, I've got a V that's 18 miles at 45 degrees. And I've got a 32 miles at an angle of 110, and I've got a 28 miles at an angle of 200. All right, so V, W, Z. All right, so I got my vectors. Now, in order to get a 32, see so I'm going to go that way, and then I'm going to go this way, and then I'm going to go that way. Okay, so that being the case, if I say 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, that ought to be okay. So I'm going to go up in 5s. is what I'm going to do. Okay, so that being the case, okay, so we're going to go up in 5. So we're going to go and put my protractor there, and we're going to put, way to go. I'm going to go and get on an angle of 45 degrees, which is right there. And then we want to go 18 on that. All right, so we'll bring down our ruler, and it looks like 5, 10, 15. Every inch is 15. Now, can I rotate my ruler? Why can't I rotate my ruler? Bummer. My ruler isn't rotating. Well, thank you, ruler. Oh, there we go. Now I'm rotating. Okay, so I'm going to rotate my ruler. And then, oh, way to go, way to go. Grab the wrong thing. And I'm on my ruler. Okay, so what did we say the ruler was?
Every inch is 15.
Every inch is 15? So if every inch is 15, I'd want to come out to there for 18. All right, so now I've done the first guy. Okay, that's fine. So I move my ruler out of the way. I then will go to my protractor. Protractor. Don't you understand the word protractor? I said protractor graph. No, not that guy. No, not that guy. No, the protractor. There we go, I got it. I got it. I got the protractor now. No, I don't have the protractor. Darn. No, that's not the protractor. That's the protractor. Okay, there we go. So I bring the protractor to there, and then I want an angle of 110. So I come around to 110. Okay, so now I'm on an angle of 110. And we'll change colors, and we'll come that way to 110. Okay, excellent. Then we'll move the protractor out of the way. These guys are not listening to me. Okay, we'll move the protractor out of the way. We'll put in that guy there because we're going to keep him. Okay, now we want 32. So that's a little over 2 inches. So we'll come up on the ruler again and get the ruler going the right way. Not you. Not the ruler. Okay, so I got the ruler going the right way. So, oh, I don't want to be there. I want to be there. Okay, so there's, it's a 1/2 inch every 15, right? So it's a 1/2 inch every 15. So there's 30. So 32 would be right there. Okay, so now I've got that one. Now I'm going to go move the ruler out of the way. Thank you very much. Not listening. This must be a kindergarten class. Yes, it's not listening to me. All right, now we're going to come from there, and we want an angle of 200. And I'm not going to get a 200 from here. So I'm going to swing it around. Okay, so 200 would be 20 degrees off of 90. So I'm 20 degrees already, so that's 180 plus another 20 would be 200. Okay, quit smiling over there, Ben. I can. Anyway, so I'm coming this way, and I want to come 28. And 28 is a little bit less than an inch on my ruler. So I'll put this guy over here and grab my ruler. Take my ruler around. So it's a little less than an inch. And what color haven't we used? We haven't used the red guy. Okay, so it's right there. All right, so that's where we are. So that's very good. And now I need something for my answer, so I'll use that guy for my answer. So my answer is going to be this guy right here. Well, not that guy right there, but yeah, like Oh yeah, like that. All right, now, well, that was really bad. Why don't we go and get a line? That would be better. So my answer, my right answer would be sitting like, you know, if I went and got a line with a delete that guy. I will get a line that has an arrow on it. Wouldn't that be better? Does that have an arrow on it? Yeah. Oh, isn't that professional looking? So there's my answer. We'll call it the resultant. R is right there. So now I need to know the angle and the magnitude. So we take our ruler and we measure how long it is. Way to go. Okay, grab the ruler, and I've got 1 inch. No, I don't. Can't move you. All right, so I've got 1 inch for 30, and then I've got another half, almost a half. So it's not quite 45. We'll call it 44. So I got 44 miles, and then what angle do I have? Well, I would move my ruler out of the way. No, not the graph. Move the ruler out. Well, I could move the graph out of the way, I suppose. And then we want to go and measure the angle. So we'll turn this guy back that way. Okay, so we're like that. And we're going to measure the angle as 125. Angle 125 degrees. And that'd be our final answer. And again, if I'm doing this without protractor and without a ruler, I'm not going to get very accurate results, right? All right, moving on to 12. Let's see. I'm going to move some of these things out of the way so you can see what we're doing better. No, you don't really care, right? But now we know that we're going to use real lines for our vectors next time, so we're more professional. And did we mark that as number 7? Yes, we did. All right, so that's good. So now we're moving on to number 12. So the key in doing a graphic vector addition is you're not going to get the right answer, right? The 2 or 3 significant digits. So if you put down 2 or 3 significant digits in your right answer, I know that you didn't do it the right way, because you're not supposed to do that. A plane is flying 300 miles an hour on a compass heading of 40 degrees west of south. All right, so we know here. So here's south. West of south would be that way, and 40 degrees west of south. So we have a plane doing 300 miles per hour at an angle of 230 degrees. All right, so that's my plane. And we have a wind blowing 60 miles an hour, is blowing from the east. So we got a wind blowing from, here's east, from the east, it's going that way, at 40 miles an hour, 60 miles per hour, 60 miles an hour at an angle of 180. And we want to know what direction, what is the true course of the plane and what is its ground speed. Okay, so that's what we're going to go for. And we're going to need an X, well, do we really need, yeah, we should probably have an XY plane because that's more fun if we have an XY plane, right? So we got an XY plane, and then we need a compass. And where did we get our compass from? Measurements and shapes, area, angles. We'll look at angles this time. And do we have what it would be nice to have would be a protractor with a ruler on it. That's really what I want. Okay, but I don't get that. I can't have a protractor with a ruler on it. I can only have a protractor. And now we'll forget about this ruler thing because it's pretty hokey anyway, right? Right now, clearly we're coming here at 300 miles an hour. So if we go 100, 200, 300, that'd be good. All right, so we'll scale up to 100 right there, 200 right there, 300 right there. So 50 everyone. Okay, so first thing we need to know is, well, we'll go with the wind first. So the wind is doing 60 miles per hour at an angle of 180. Well, that's pretty cool. We can just come here and go there. So there's 60 miles an hour, 180. I wonder, can I have these in different colors? Yes, I can. That'd be really cool. Okay, back to what I was doing. Now we want to be in a direction of 230. All right, so we take our protractor and we put it there. And this protractor is different than the last one we had, isn't it? Yes, it is. So an angle of 230. 230. Right there, right? So that's my angle I'm looking at. So my plane's coming out this way some distance. Probably further than that. All right, so we're gonna move this guy out of the way, and then we're gonna say, okay, I gotta come out 300. 300. How am I gonna do that? All right, I'll do it with my finger. Okay. 100, 200, 300. That's about right there. 100, 200, 300. Let's go in and put a circle here. Okay, so there's 100, there's 200, there's 300. Well, that was a really bad guess, wasn't it? So, let's see, can I grab that guy? Yes, I can. And then I can move him back to there. Oh, excellent, excellent. Okay, so we have that guy. All right, so that's good. So now we're going to go and put my answer in. So my answer is going to come from here and go to there. Okay, so that's my answer. And now I'm going to have to measure my answer. So I need the angle of that guy. So I'm going to rotate him around like that. Oh, much better. So that's 45 more degrees than 180. So that would be 225. Is that what that is? So my final answer, my angle is 225 degrees. And then I want the length. All right, so I'm gonna move this guy out of the way. I'm gonna do this circle thing again. Now, if I had a compass, this would be really good, right? So I'm going to come from there, and I'm going to go out to there. Okay, that looks good. I'm going to call it 335. 335 miles per hour at an angle of 225. Yes, yes, we did it. So we have done section 11.5. Clearly, if you don't bring a protractor and a compass to the next test, the chapter has other ways to solve these problems, and that will not be one of your favorite ways of doing it, so you probably won't be doing that ever again in your life. But at least you saw it done, And if in the next life you happen to be a sixth grade math teacher, then you're all set. You can now do compass. You can now do vector addition using graphing. All right, so everybody's happy with that. I can just imagine. Okay, now we come to probably my least favorite way of doing vectors. So we're in section number 6. And what we're going to do is we're going to solve adding of vectors. We're going to add vectors A and B, and we're going to use trigonometric methods, which implies that we're going to use the law of sines, and we're going to use the law of cosines, and we're going to use Pythagorean theorem, and we're going to use sines and cosines because, you know, sines, cosines, tangents. All right. So of all the pain in the rear end ways to solve a problem, this is probably the worst idea ever dreamt up by man to solve the problem this way. And that's why I only have 2 assigned as homework, because it's going to take me the rest of the class period just to do those 2 by these glorious methods. Now, what method are we really going to use to solve vectors? Anybody know yet? Your calculator. Your calculator. So let's move back for a moment to look at the last graphing problem. All right. And the last graphing problem said 300 angle 230 plus 60 angle 180. That's what the problem said, right? So I'm going to take out my calculator. I'm going to hit the on button. I'm going to put the mode of my calculator in. I have a choice between real and A plus BI. I'm going to put it in R angle theta mode, which is a polar mode on my calculator. All right, so my answer is going to come out in R angle theta. That's what it's going to do. Then I'm going to put in 300, second function complex, 1 for an angle, and I'm going to put in 230. And then I'm going to put plus 60, second function complex, 1 for the angle, 180. Hit the enter button, and my calculator is going to tell me that the answer is 341.672875.6 at an angle of minus 137.731 degrees. Well, I don't have that many significant digits, so we say, well, you probably only have 2. So, did I have 3 in the problem? I don't remember. Anyway, so we'll call it 242 at an angle of, well, I don't like that angle, so 360 minus 137.73 at an angle of 222 degrees. So that's what my calculator tells me. And then I come down here to my final answer. Well, that's pretty good, right? But yeah, my favorite method of solving vectors is going to be on my calculator doing it for me. But unfortunately, we are now in section 11.6, where we get to use the trigonometric methods. All right, so 7.6, problem number 3. All right, so I got vector 1, 4.50 kilometers at 67 degrees, and vector W, 6.50 kilometers at 105 degrees. Okay, so that's what I've got. And now I have to find the sum, V plus W. All right, so I got myself a pretty graph, and I come up this way, and I come up that way, 4.5. On this side I have 67 degrees. Well, if I have 67 degrees on this side, what do I have on the other side? 23 degrees, right? Okay. Then I'm going to go and draw an XY set of axes there so I don't get confused. And then I'm going to go at 105 degrees. I'm going to go 6.5. So now I know that this angle is 105. And what am I looking for? I'm looking for that. Okay, so I have two sides and an included angle. I can use the law of cosines, but I don't know this angle yet. All right, so I got to come up with this angle. So I say, well, a transversal going through two parallel lines, alternating interior angles are equal. I remember that from 9th grade geometry. So if this is 67 there, this has to be 67 down there. Alternate interior angles. And then if this is 105 and the whole thing's 180, then this has to be 75 on this side. And if that's 75 on that side, 75 and 67 is 142 degrees. So now I can find the magnitude of my resultant using the law of cosine. So r is going to be the square root of 4.5 squared plus, is it 6.5 squared minus 2, 4.5, 6.5 cosine 142. Isn't that lovely? That is just so lovely. I can find that number. Now, due to our ability yesterday of never being able to put it in my calculator and getting the right answer, I suppose the same thing's going to happen today. 4.5 squared plus 6.5 squared minus 2 times 4.5 times 6.5 times the cosine of 142. And I end up with 10.4 kilometers. Am I done? No, I'm not done yet. I still need to find this angle. Okay, well, how am I going to find that angle? Law of sines. Okay, so the angle I don't want, because I'm going to find this one here. So my angle A, I'm going to call that big A. All right, so A, which is 6.5, divided by the sine of A, is going to be equal to the 10.4 guy divided by the sine of 142, right? Yes, it is. So that means A is going to be the arc sine of 6.5 sine 142 divided by 10.4. Okay, now, I'm not going to use 142. Yes, I am. I don't have a choice. Darn. I thought I had something else, but I don't. All right, so I go, wait a minute. I'm not going to use 10.4 because I'm going to use 10.421066666 in my calculator when I get to that. Okay, so back to the arc sine function. Arc sine 6.5 times the sine of 142 divided by the answer that I had. And I'm going to have that A is 22.58 degrees. All right, well, I probably don't have that many significant digits, so I'd probably call it 23 degrees. All right, so if A is 23, 23 and 67 is the angle that I'm at. So 23 plus 67 is equal to 90. 90? Really? You mean this guy went right up there? I guess he did. My picture is pretty bad. And now I'm ready for a final answer. Final answer. 10.4 miles at an angle of 90 degrees. Okay. But in order to solve the problem, I had to recognize Okay, I can use law of cosines, and then I can use law of sines, and then I can get an answer. All right, was that okay? Yeah, why not? Number 14. En route between two cities, a car travels 100 kilometers west, 120 kilometers southwest, then 150 kilometers south. Find the displacement from the starting point. And only use trig methods. Okay, well, that's okay. We can handle that, I suppose. Okay, so my first vector is 100 to 3 significant digits, kilometers, at an angle of 270, 180. And my second vector is 125 kilometers, and then we'll come over here and draw something, and it's southwest, so that's that way, and that makes this 45 degrees, so that'd be at an angle of 225. All right, and then we'll use Z, I guess. Z is 150 to 3 significant digits at an angle of 270 due south. All right, so that's what I've got. So now I'll draw a picture. And what I need to do is I need to solve the first one before I can solve the second one. All right, so I'm going this way at 100. And then from there, I'm going to go that way for 125. So that means I want to know that magnitude in that direction. Okay, so I need to know this interior angle, and that would be 180 minus 125. This is 225 that way, right? This is 45, so that's 135. So 135 would be that interior angle. All right, so that being the case, I want to find this R, and I find that, do I really want to do that? Yeah, that's what I really want to do. So R is going to be the square root of, this is 125, the distance of that guy is 125. I want to keep that. 125. So I got 125 squared plus 100 squared minus 2 times 125 times 100 times the cosine of 135. All right. Square root of, thank you very much, calculator, for going to sleep, 125 squared plus 100 squared minus 2 times 125 times 100 times the cosine of 135, close parentheses, 208. 208. All right, so I know that this is 208, and now I want to find that angle. Okay, we'll call that A. Okay, so using the law of sines, I have that 125 over the sine of A is going to equal 208 over the sine of 135. And I find that A is equal to the arc sine of 125 sine 135 divided by 208. All right, so arc sine of 125 times the sine of 135, close parentheses, divided by the answer that I just had, close parentheses, equals. So I get my A is 25.1 degrees, and I have 3 significant digits, so I should keep it that the 3 significant digits. All right, so this angle is 25.1 degrees. Okay, halfway done. Halfway done. So I'm going to come down. I'm going to redraw the picture, and I'm like that. And I have this new guy coming this way at 208 and 25.1 degrees, 25.1 degrees right there. And then I'm going to go due south, I think. Yes, 150. I come that way. 150 down to there. And now I want to know that length and that angle is what I'm looking for. Okay, so what I want to find is this interior angle. That's what I'm looking for. All right, so I'm going to put in an XY plane. I'm going to dot in an XY plane right there. And I'm going to say, if this is 25.1, then clearly this side is also 25.1. And if that side is 25.1, then this bigger angle has to be 90 plus 25.1, which would be 115.1. All right, so now I'm solving for a new r. That new r, using the law of cosines again, square root of 150 squared plus 208 squared minus 2 times 150 times 208 times the cosine of 115.1 degrees. Okay, put it in a calculator. Square root of 150 squared plus 208 squared minus 2 times 150 times 208 times the cosine 115.1. Close parentheses, close parentheses. So my distance r is 303.7. And are we in kilometers or are we in miles per hour? We're in kilometers. My final answer is only going to be the 3 significant digits, so the final answer for that is going to be 304 kilometers. Okay, now we're going to come back and find my angle. All right, so got to come back and find the angle. So we'll call this A again. So 150 divided by sine A is equal to 303.7 divided by sine 115.1. A is equal to the arc sine of 150 sine 115.1 divided by 303.7. Arc sine 150 times sine 115.1 divided by the answer that I just had, so I can have lots of significant digits. And my answer is 26.56 degrees. 26.56 degrees. Obviously, I can't have that many significant digits, but I'm looking for this angle. That's what I want to know what it is. Well, I don't even want to know that angle. Because the question was written in a silly Air Force flying south of west, east of north type thing, then we're going to want our answer to be the same way. So basically we want this angle, and we're going to call it west of south. That's what we're going to do. All right, so 90 minus 25.1 minus the answer I just got is going to mean this angle here is 38.3 degrees. So my final answer is going to be 304 kilometers at 38.3 degrees west of south. Oh, yes, yes. Now, what we'll do is we'll go back to the top of the problem and put it in our calculator and see what we get. See if we're even close. All right, so I got 100 second function complex angle 180 plus 125 second function complex angle 225 plus 150 second function complex 270. Oh, bummer, I hit the wrong button. Clear the whole thing. 100 second function complex angle 180 plus 125 second function complex angle 225 plus 150 second function complex 270. How come it did that? And so that's obviously wrong. Do it again. I'm doing it again. 100 second function complex angle 180 plus 125 second function complex angle 225 plus 150 second function complex angle 270. Enter. And my calculator says, without doing any of those other things, 303.84 at an angle of minus 128.3. And I'm going to take the minus 128 plus 0.3. I'm going to minus 128.3, and I'm going to add, what am I going to do? I'm going to add 180, so that'd be a 51.7, and then I'm going to subtract 90 and 38.3. So this would be 304, because I only have 4 significant digits, and I'd be 38.3 west of south. Is that what I had? Yes, it is. Yes. So our calculator makes this entire chapter a whole lot better than what we could possibly think that it could. Okay, any questions? But it did take me 20 minutes to do two problems, right? Yeah. Except I could have done it in my calculator and had the answer much sooner. So that would have been much better. And Wyatt is looking worried again. Are you worried again? Oh. You're just worried because Ben's laughing too loud. Is that it? Yeah, okay. That's it. Okay, so